Mr. Clelland here for Clelland Maths. Today we're looking at National 5 Maths and we're looking at gradient, which will lead straight on to straight line next week. But gradient to start with, just on gradient, is vertical over horizontal. It's the slope, it's how steep this slope is. And if I've got a triangle, I can draw it out and just think I've got vertical side over horizontal. But in National 5, we then have to do it without the actual slope and just from coordinates. And I'll give you the formulas and everything else you need. So stay to the end to also see some strange past paper questions on this. But what is gradient? Well, where we go, we know it's vertical over horizontal. So I've drawn a coordinate grid to kind of remind us of this. And I've got a line here. So if I want to know the gradient, what I can do is I'll use red, kind of just make a triangle. So I've went down and I've went along, and we can then count the boxes. So I've got 1, 2, 3, 4, 5, 6, 7, 8 along, and 1, 2, 3, 4, 5, 6, 7, 8 high. So we can say the gradient, and I'll just use m, because m is usual gradient, is vertical over horizontal. 8 divided by 8 is 1. So that's a gradient of 1. But what about ones that slope down the way? So this one slopes down the way, but we still make a triangle. And joining that up, we've got 1, 2, 3, 4, 5, 6 down, and 1, 2, 3, 4, 5, 6, 7, 8 along. So you might be tempted to say the gradient is 6/8, but you'd be wrong. Because ones that slope up the way start low and go high are positive gradients. But ones that slope down the way, start high and get lower, are negative gradients. So you need to remember to put a minus on this when you're sloping down the way. So we're counting down the way, so it's minus. Simplify fractions, divide top and bottom by 2 to get minus 3/4 as our gradient for this line.
Clelland Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code ClellandMaths at leckyscotland.co.uk, and these are excellent because we have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code ClellandMaths. The links are in the description and down below.
Last thing I'm going to look at on this diagram is what type of lines are these? Well, these are called parallel lines. We call them parallel lines. And the good thing about parallel lines is the gradient's exactly the same. So if I was to work out the gradient of this one here by going this way, I would have 1, 2, 3, 4, 5, 6, 7. I'd have 1, 2, 3, 4, 5, 6, 7, 8. The gradient of, let's call this line 1, is 8/7. Now let's look at the other one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Again, on line 2, the gradient is also 8/7. Parallel lines have the same gradient. That's the key thing. Parallel lines have the same gradient. Okay, let's move away from a full grid and put some numbers in the grid. So I've put some numbers in. So we could do it by counting boxes, still the same way. Just make a straight line and straight line. 1, 2, 3, 4, 5, 6. So as long as it's going up in ones, we can count the boxes. 1, 2, 3, 4. So our gradient for this one is 6 over 4, which is 3 over 2. What about if I draw a line like this, where it's not really ending at the corner of a box, so I can't count from here going a long way? Well, what you do is, you find one that you can count from. So I can start here and find another one like, I think this one's kind of in there, and draw the triangle from there instead. And because these triangles will be similar, whether I draw it there or draw a big one, the ratio of the sides will be the same. So I can just count them instead. 1, 2, 3, 4, and 1, 2, 3. Now remember, this is a negative gradient because it's going down the way, so it's minus 3 quarters. And there we are. Looking at this example, what about this one? Can we find the gradient of that one? Well, never exact, because it's not actually touching any corners. So it's going to be a really funky gradient. So the only thing you could do is get your best guesstimate, but what you're actually going to do is, if I gave you some coordinates like here and here and told you those coordinates, you could work out the distance there and there and work out the gradient from that. And that's what we're going to look at next. So I'm going to call this point x1 and y1. And I'm going to call this point up here x2 and y2. And we can work out this distance here and here. And the question becomes, how long is this and how long is that? So let's go back to here. We know this coordinate is minus 3, 2. Let me just write that, minus 3 and 2. And this coordinate is 1 minus 1. If I want to know the distance from here to here, I can count the boxes, or I can check how far apart are minus 3 and 1. So that's essentially the same as saying, what's the difference? So it's the difference between 1 and minus 3 is 4, and the difference between 2 and minus 1 is 3. So to do your gradient, you could just do this number minus this number. 2 minus minus 1 is 3, and minus 3 minus 1 is minus 4. And I would have a minus in it to show my negative gradient straight away. Or I could go the other way. Minus 1 minus 2 would give me minus 3, and 1 minus minus 3, minus minus makes a plus, gives me 4. As long as I do the difference between the x's and y's, I will get my gradient. So in other words, with a general thing like this, x1, y1, x2, y2, we just say our gradient, and this is now called the gradient formula, is y2 minus y1 over x2 minus x1. And that's the key gradient formula for National 5 Maths, and we'll be using that all the time now. Okay, example 1. Remember, examples like this are taken from maths.scot, an excellent website for your revision. Find the gradient of a straight line between these. So we call that one x1 and y1, and that one x2 and y2, and we write m equals y2 minus y1 over x2 minus x1, subbing in minus 7, minus 5, getting the numbers right, 3 minus, then minus 1. There's a minus in the number and a minus in the formula. Minus 7 minus 5 is minus 12, 3 minus minus 1 is 4, dividing that through we get minus 3. So what's your negative number work here? Example 2 for gradient, find the gradient of a straight line joining these points. So we've got x1 and y1. I always just call the first one and the second one like this. I write our gradient formula, y2 minus y1, x2 minus x1. So I've got y2's minus 11, minus, then y1's minus 5, x2's minus 2, minus x1 is 2. So I've got minus 11, add 5, so minus 10, 9, 8, 7, 6. Minus 2, take away 2 is minus 4. Simplifying the number parts, forget the negatives for now. Divide by 2, you get 3 over 2. But a minus divided by a minus is a plus. So these cancel each other out. If you end up with 2 negatives, one on the bottom, one on the top, you just leave your answer as a positive answer, and you're done there. Okay, example 3. Determine the gradient of the straight line joining 1, 4 and minus 6, 4. x1, y1, x2, y2. I'm going to show you what happens here, but then I'm going to show you something else with this in a minute. y2 minus y1, x2 minus x1, 4 minus 4, minus 6 minus 1, that's 0 over minus 7. Anything divided by 0 is 0, so the gradient is 0. And you would realise that if you looked at the second coordinate. If the second coordinate's the same, it's going to be a horizontal line, so it's going to be 0. See this one then, Example 4, x1, y1, x2, y2. Keep your head on. Gradient is y2 minus y1 over x2 minus x1. That's 0 minus minus 4 on the top, minus 3 minus minus 3. That gives me 4 over minus 3 plus 3 is 0. Oh no, I'm trying to divide by 0, so it's undefined. Remember, we say it's undefined if you divide by 0. In other words, this is a vertical line. One way to check that again is, if the first coordinate number is the same, it's a vertical line. Example 5, the vertices of a quadrilateral are, prove that AB is parallel to CD. Well, we don't even need to draw it out. We're looking at the gradient of AB and the gradient of C to D. So let's do AB first. Minus 7 minus 5 over 1 minus minus 2. Minus 7 minus 5 is minus 12 over 3 is minus 4. C to D. Minus 10 minus minus 2 over 7 minus 5. Minus 10 minus minus 2 is minus 10 add 2, which is minus 8. Over 7 minus 5 is 2, which is minus 4. Same gradient. And we've seen earlier that that means they're parallel. Okay, example 6. The gradient of a straight line through 1, 5 and minus 2p is 4. Find the value of p. So a little bit of problem solving here. x1, y1, x2 and y2. But don't be worried. We'll just sub it in. So m equals y2 minus y1, x2 minus x1. That's p minus 5 on the top, minus 2 minus 1 on the bottom, and that equals 4. So that gives me p minus 5 over minus 3 equals 4. So times in both sides by minus 3. That gives me p minus 5 is minus 12. Add in 5. Minus 12 add 5 is minus 11, 10, 9, 8, 7. So p is minus 7. And we're done there. The gradient of a straight line through 1a and a minus 1 is 2. So same again, x1, y1, x2, y2. y2 minus y1, which is a, over x2, which is a minus 1, equals 2. Top times bottom, minus 1 times 1, that times that. Minus 1 minus a equals 2 times a minus 1. Minus 1 minus a equals 2a minus 2. Add in a, we get 3a on this side. Add in 2, we get 2 minus 1 is 1. And therefore, a equals 1 over 3. And we're done there. SQA National 5 Maths 2019, Paper 2, Question 13. Find an expression for the gradient of a line joining 6, 9 and 4p squared. So x1, y1, x2, y2. We have to simplify our answer. y2 minus y1, 4p squared minus 9. Over x2 minus x1, 4p minus 6. So there's step 1. But now we need to simplify it. So this is tying into algebraic fractions. We'll see my video on that. Simplifying the top's the difference of two squares. So that's 2p minus 3, 2p plus 3. And factorise the bottom. 2 comes out to get 2 times 2p. 2 3s is 6. They cancel off to get 2p plus 3 over 2. And we're done there. It's been Clelland Maths today. We've done the whole of gradient for National 5 Maths. Next week we'll do straight line, which ties in with gradient again. Take care, stay safe, and goodbye.